Hey, welcome back everybody. So we continue with Perms and Columns today, lesson 2, factorial notation, and we're going to learn what that is all about. In the last lesson, you may have noticed certain questions like calculating the number of ways of arranging 6 different books side by side on a shelf would have been, well, 6 choices for the first position book, 5, 4, 3, 2, 1, right? That happens a lot where you have those kind of numbers keep decreasing by 1. And as a result, they came up with a shortcut way of writing that, and that's what factorial notation is. So if it's 6 times 5 times 4 times 3 times 2 times 1, that's denoted by 6, and I know it's an exclamation mark, so it's not 6, it's 6 factorial is how you say that. Okay, and that way that implies that it's 6 times 1 less than 6, 5 times 1 less than 5, 4, all the way down until you reach 1. Okay, so without using a calculator, let's look at finding the value of 4 factorial. So that would be the same as 4 times 3 times 2 times 1. And if you multiply that out, 4 times 3, 12 times 2 is 24 times 1. Okay, next one, 3 factorial times 2 factorial. So 3 factorial, 3 times 2 times 1, times 2 factorial, 2 times 1. And that will become 6 times 2, which is 12. And there we go. Now, here's something with factorial notation. You cannot multiply factorial notation. So 3 factorial times 2 factorial does not equal 3 times 2, which is 6 factorial. Okay, because you'll notice with 3 factorial times 2 factorial, we got 12 as our answer. Up here, 6 factorial is actually equal to 720. So significantly different. So you can't multiply factorials like that. Okay, now 6 factorial can be written in a number of ways. Like I could expand all the numbers all the way down to 1, or I can stop at any point, throw the factorial back on, which means essentially that number times 2, like in this case 6 times 5 times 4 times 3, and then if you write factorial, that essentially means 3 times 2 times 1. Okay, so I can stop here at 4 and throw on the factorial, implying that this part here is 4 times 3 times 2 times 1. Okay, get the idea? So by doing that, we can actually simplify quotients of factorials. So 6 factorial over 4 factorial, what I could do is expand 6 factorial so that it's 6 times 5 times 4, throw on the factorial, and then the 4 factorial in the denominator could actually divide into the 1 in the numerator because everything's multiplied together on top there. And you're left with 6 times 5, which is 30. So it's a way to simplify a quotient. Okay, let's look at 5 factorial as a product in 4 ways. So the idea here is you could write it as, say, 5 times 4 times maybe 3 factorial. Or we could go 5 times 4 factorial. Or let's see, one we haven't tried yet, 5 times 4 times 3 times 2 factorial. Okay, any we've missed? Or we can expand the whole thing, 5 times 4 times 3 times 2 times 1. And there we go. Okay, complete the following. So if I have 12 factorial and I want to write it as something times 11 factorial, I could start with 12 and then times, and if I don't want to continue from there, I just go 11 factorial, and that implies I have all the rest. Okay, 8 factorial. Let's see, we've got something times 6 factorial. Well, I know 8 factorial would have to be 8 times 7 and then times 6 and down. So that means this would be 8 times 7 times 6 factorial. Good, let's try the next one. D, express as a quotient of factorials. Okay, well we've got 6 times 5 times 4 and then nothing else, right? Which means the times 3 factorial must have disappeared. Like it must have been times 3 factorial, which canceled with a 3 factorial on the bottom. So as a result, what it must have been on top was 6 factorial, right? 6, 5, 4, 3, 2, 1. And then the 3 factorial on the bottom canceled off with 3 factorial on the top. Okay, so using that idea, why don't you guys try what the next one would look like? If you want, pause your video. Okay, so the top, basically what's missing is 11 factorial down, because that canceled with an 11 factorial on the bottom. So on top we would have 15 factorial, on the bottom 11 factorial. Okay, did you get that? Good job. Okay, E, without using a calculator, simplify. 10 factorial over 7 factorial. So the idea is to expand your larger factorial. So 10 factorial would be 10 times 9 times 8 times 7, and we could keep going, right? Times 6 times 5 times 4. But notice the one on the bottom is a 7 factorial, so why don't we stop at 7, write 7 factorial, and then we still have 7 factorial in the denominator, so that means we could divide that, okay, and then we'd be left with 10 times 9 times 8, which equals 720. Good way to multiply that out, go 9 times 8, which is 72, and then times 10, add a 0. Okay, let's look at the next one. 8 factorial over 5 factorial, 3 factorial. Okay, well, let's expand the larger one again, 8 factorial. 8 times 7 times 6 times 5. Now, how do we know when to stop? Well, we have a 5 factorial in the denominator. If we stop at 5 factorial in the numerator, that means we can get rid of the rest of it. So 5 factorial, and then we still have 3 factorial on the bottom. But you know what? Let's expand that. It might be easier to work with. Okay, so the 5 factorial can divide, including the factorial. Make sure you cross out both. And then you'll notice on the bottom we have 3 times 2. Well, what does that equal? That equals 6. So therefore that can cross with the 6 on top. Final answer, 8 times 7, which is equal to 56. All right, good job. Let's look at the next page. Okay, so in general, what we've discovered about factorial notation is if you see something like n factorial, we basically start at that number, write that, then times one less than that number, and one less than that number, and one less than that number, and we would keep going until we reached 1. Okay, n, however, has to be an element of the whole number system, so nothing smaller than 0, and they all have to be like whole numbers, so 0, 1, 2, 3, 4, that kind of thing. All right, now 0 factorial is equal to 1, and we'll get to why that is in a little bit. N factorial, as we discovered with the numbers on the earlier page, can be written in a lot of different ways. We could start with n and then drop 1 and n minus 1 factorial, or go a little further down to n minus 2 and then throw in the factorial, etc. So we're going to work basically what we did on the previous page, but now we're using n. Okay, so n factorial, if I wrote it as something times n minus 1 factorial, well, to expand that, I would have started with n, and then times n minus 1, n minus 2, yada yada. So that's all we're missing is the n. Okay, n plus 2 factorial. This one can be a little trickier. If we go to expand that, of course we start with the n plus 2. Okay, then the next factor would be 1 less than that. So n plus 2 minus 1, which would be n plus 1. And then 1 less than that would be n plus 1 minus 1, which is n. Oh, and there it is there. So there we go. We've got it expanded. Okay, next one. A little bit trickier yet. N minus 4, n minus 5, n minus 6. Now you're going to think, hey, but that's getting larger. Not really. If you subtract 1 from negative 4, you actually get negative 5. If you subtract 1 from negative 5, you actually get negative 5 plus a negative 1, so negative 6. Awesome. So now they want us to turn that around and write it as a factorial. Well, our highest factor or biggest factor is actually n minus 4. So our factorial would be n minus 1 or n minus 4 in brackets, and then factorial. Okay, awesome job. Let's look at example 2 here. Simplify the following expressions. Leave the answer in product form where appropriate. Okay, so we have n plus 2 factorial over n factorial. So just like with the numbers on the previous page when we were simplifying without a calculator, we want to expand our larger factorial. And it's not as easy to determine that when it's n, but if you're ever stuck, you can sub a number in for n. Like let's say n was 5. So we'd have 5 factorial on the bottom, 5 plus 2, so 7 factorial on top. So that makes the numerator bigger. Anyways, let's start expanding. So n plus 2 is bigger, so we start with expanding that. N plus 2, then 1 less than that, n plus 1, 1 less than that would just be n, and now we're at the one that's on the denominator, so we throw our factorial on. all divided by n factorial. That factor, n factorial, can cancel off or divide to equal 1. And then in the question they said leave it in product form, so we'll just leave it as n plus 2, n plus 1. And there we go, that's your answer. All right, next one, I'll give you a little hint to get started. Sub in a value for n, like something bigger than 2, maybe like a 4 or 5, to figure out which is larger, and then expand that larger one. Okay, so if you want to give that one a try, why don't you pause your video and then we'll go over it in a second. Okay, pause your video. Okay, so if you subbed in a number like 5 for n, you'd discover that on top we have 5 minus 2, so 3 factorial, and then on the bottom 5 minus 1, 4 factorial. So the bottom's bigger, okay? So you would start by expanding that factorial notation, so n minus 1, 1 less than n minus 1, n minus 1 minus 1, so n minus 2 factorial. We've hit the one that's on top, so we stop there, throw our factorial on, now we cancel off both of those factors. Now, the answer would not just be n minus 1, okay, because when you divided n minus 2 factorial by n minus 2 factorial, it actually left a 1 behind on top, so we have 1 over n minus 1. All right, next one. Okay, n factorial really is our only factorial, so our only choice is to start by expanding that. So n, 1 less than n minus 1, and whoops, what happened there? Hang on. There we go. Okay, it's back. All right, so we expand the n factorial, n minus 1, n minus 2. Now I could keep going forever, right? N minus 3, n minus 4, etc. But the denominator, not that it has a factorial anymore, but the factors in the denominator were n and n minus 1. And now I have those factors in the numerator. So n minus 2 factorial is the last one I would need to write. Okay, so both those factors go, and our final answer would be n minus 2 factorial, and that would be it. All right, example number 3. This one gets interesting. Basically, on the left-hand side, we want to solve this equation, but when it has factorial, we need to do what we did in example 2 to kind of get it simplified. So let's look at this. N factorial over n minus 2 factorial. Well, the numerator is bigger, so we're going to start expanding there. N minus 1, 1 less than that, n minus 2, and now we've hit the denominator one, so stop there, throw the factorial on, and that's over top of n minus 2 factorial equals 42. Okay, so now you'll notice that that n minus 2 factorial can divide, and we'd be left with n times n minus 1, and I'm going to multiply that through this time. Okay, now take a look at what you have. We seem to have a quadratic equation because we have n squared and an n. So in order for us to solve this, we need 0 on one side. Okay, so we take that over. Now we can factor it. So n times n multiplies 42, adds to negative 1, so that's going to be 7 times 6, negative 7, positive 6. Branch each one off. N would equal 7, and n would equal negative 6. And there we go. Oh, wait. Now, logically speaking, if we're dealing with factorial notation, we can't go any lower than 0 for our n value, right? So because n has to be greater than or equal to 0, or, let's write it this way, n is an element of the whole numbers, that would eliminate our answer of n equals negative 6, making n equals 7 our only solution. Good. Let's look at the next page. Okay, next section is looking at how to do factorial notation on the calculator. And to get 6 factorial, you would type in 6 first of all, go to Math, and then over to PRB, which stands for probability. And you'll notice number 4, so you just hit number 4, and there's our factorial. And we would get 720. Okay, and then what you're going to do is you're going to go get what 9 factorial is. They talk about how to do 10 factorial over 7 factorial, 3 factorial. The big thing with that is you need to have brackets around your denominator when you put it in the calculator. Okay, so why don't you guys go ahead and do example 4 on the calculator, and then so come up with these values, and then in part 2 of our video, we'll go over those and finish up this lesson. Okay? Good job. We'll see you in part 2.